Hello everyone, welcome back to our Smart Interviews YouTube channel. My name is Dheeraj and today we are going to solve the first 4 problems from the CodeChef Starters 183. So let us go ahead.
So let us go through the first problem, IPL. The problem name is IPL. Okay. So let us see the problem statement. Chef has already prepared dinner and it's his favorite time of the day. Okay. It's time for a fantastic cricket match tonight. Assume there is a match happening tonight and chef has already prepared the dinner. Okay. So in the first over, if the cricketer has scored at least seven runs, then he will simply say Tala. Okay, or else he will simply say boom. Okay, in the first over, if he scores, whoever the batsman is, if he scores at least 7 runs, then he will simply say Tala. Okay, or else he will simply say boom. So you will be given an integer x. This value will be given an integer x. So you just have to decide whether you will be saying Tala or whether you will be saying boom. Okay, so let us go through the constraints. If you can see the constraints are very small. Okay, so now let us go to the sample input. So in the first sample input you are given an integer of x and here it is given as 7. Since 7 is equal to 7, right, in the first over he scored at least 7, so he will simply print Tala. Okay, now in the second sample input, the x value is 4. 4 is less than 7, right? So in this case he will simply print boom. So I don't think there is much discussion needed here because this is just one if condition code, right? So let us jump into the code now. Okay, so let us write the code for it. Okay, so first you need to take the integer x as input. Okay, so let me take the input. So if the x value is at least 7, which is equal to 7 or more than 7, then you will simply print Tala. Okay, or else you will simply print boom. So this is the code. Now let me run it. Okay, sample test case is getting passed. Okay, so this is all about the first question. Now let us jump into the second question now.
So let us jump into the second question of the division 4 problem from CodeChef Starters. Okay, so the question name is bar Q. Okay, so let us try to read the problem statement. Chef is throwing a grand party at a bar and there is already a queue at the entrance waiting for the event to start. So you can assume that there is a bar, okay, and in front of the bar there is a big queue, and this queue can be represented as a string, okay, where each character can either be a B or G, okay, something like this, B or G. So this entire thing is a big queue. So each character is either B or G. Now what is this B? B is nothing but a boy and G is nothing but a girl. So the first character of the string represents the front of the queue. So this first character of the string represents the front of the queue. So this first person is the only person who is going to enter into the bar, right? Like he is the front of the queue, which means first in first order. Okay. So in the beginning of the entrance, there is a security guard, and he will allow only one by one into the bar. Okay. But there is a condition. Look at this condition. So, but as soon as the number of boys who have already entered the bar exceeds twice the number of girls, then the security guard closes the gate, closes the entrance. So what does this mean? So let's assume in the bar there are one boy. Okay, let's assume in this bar there is only one boy, and in this bar there are two girls. Okay, now if you see here, are the number of girls, girls twice the number of boys, right? No, right? So here the condition is not valid. So here the condition is not valid. Suppose, let's assume there are two girls and there are five boys. Now is the condition is valid? How many girls are there? Two girls. What is the twice of the girls? Two times two, which is nothing but four. So are the boys twice the number of girls, which is nothing but five is greater than twice the number of girls, which is five is greater than four. In this case, it is true. So in this case, the rest of the people will not enter the bar. And we will understand this with the help of the sample input and output. Okay. So let us focus on the sample input. So first one is nothing but the number of test cases. Next one is nothing but the length of the string, and then you will be given the string. Okay, so let us see the first one. Let me write it down. First we have one girl followed by one boy, and then one girl followed by four boys. Okay, and then one girl. So for the first test case, the answer is 7. Let us see how. So in order to track the number of boys and the number of girls who have already entered into the bar, we will try to maintain two variables. Okay, one is G, which is nothing but the number of girls, and one is B, which is nothing but the number of boys. So the first one is a girl, right? So let me allow her into the bar. So the count of girl will become 1. Okay, this is completed. Then now I have a boy. Should I allow him? Is the condition satisfied? Are the number of boys twice the number of girls? No, right? So I will allow one boy. Okay. Now girl. Should I allow? Yes, you have to allow. Okay. Now then you have one boy. Can you allow this one boy into the bar? Yes, because the number of girls are not twice is the number of boys are not the twice of the number of girls. So I will allow this one boy. Okay. Now how many, like, should I allow one more boy? Let us see. The twice of girls, like, now the number of girls are 2. The twice of girls are nothing but 4. Is 4 greater than the number of boys? No. So I will allow this one person. Okay, completed. Now should I allow one more person, which is the boy? Should I allow him, or should I stop it from here? Let us see. The number of girls who are entered into the bar are 2. Twice the girls are nothing but 4, right? Is 4, sorry, is 3 greater than 4? The number of boys are more than the twice of the girls? No. So I will allow this one boy as well. Okay, now I have one more boy. Should I allow him or not? Let us see. The number of boys are 4. Are these 4 are more than twice of the girls? Let us see. 2 times 2, because the number of girls are 2. Now here 4 is not greater than 4 because they are equal. So I can allow this one boy as well, right? Okay. Now should I allow this one more boy? Okay. So if I allow this one more boy, the count of boys will become 5. Now is it satisfying? Like, how many boys are there till now? 5 number of boys. How many girls are there? 2. Are boys twice the number of girls, which is 5 is greater than 2 cross 2? Yes, 5 is greater than 4. So what will happen is the security guard will simply stop this person from entering into the bar. Okay. So now what you need to output is how many people have entered the bar. Okay. So how many people have entered? 2 girls and then 5 boys. In total, what do we get? 7 people who have entered into the bar. That's it. So the answer for the first test case is 7. Now let us see the second one. Okay. Let us see the second one. We have B followed by one G. How many G's? 6 G's. 3 G's and then 3 girls. Okay. Now let us see the first one. How many boys count initially? Boys are 0 and then girls are also 0. Okay. So should I allow this one person? Should I allow this one person? If I allow this one person, what will happen? 1. Are boys twice the number of girls? Let us see. Is 1 greater than twice the number of girls? How many girls are there initially? 0. So is the condition satisfying? Yes. So should I stop here itself? Should I stop here itself? Yes, you have to, right? So in this case, only the one person is going to enter into the bar. Okay. So second one is also done. Now let us see the third one, which is G, B, B, and G. Okay. One girl followed by 2 boys followed by 1 girl. Let us see. So boys count is 0, girl count is 0. So the first person is a girl. Okay. Should we enter her? Yes, we can. Okay. So the girl count now becomes 1. Are the number of girls twice the number of boys? Are the number of boys twice the number of girls? No. Okay. So I can allow one more boy as well. Now let's see. Is 1 greater than 2 cross 1? No, right? So I can allow one more boy as well. Okay. Now see. Is 2 greater than 2 cross 1? No. So I can allow one more girl as well. Okay. Now is 2 is greater than, which is the number of boys, are twice the number of girls? No. So now I have completed my entire string. What does that mean? So can I simply say the entire queue, the people who are standing outside the entrance gate, all of the people have already entered the bar, right? Without even satisfying the condition. So there is no need for me to stop any people. So in this case, how many people who have already entered the bar? 2 boys and then 2 girls. So how many people? 4 people. So the answer is 4. So there is nothing to think about in this problem. Like you just need, like the moment the number of boys are exceeding the twice the number of girls, you will simply break there. That's it. So you can simply put a if condition on this, right? Or at the same way, at the same time, we have to simply track the number of boys and girls are entering into the bar. Okay. So without wasting any time, let us try to write the code for it. Okay. First, let us take the input. So the first input is the number of test cases. Okay. So I am simply running a while loop on these test cases. So for each test case, I need to take the input n value, which is the length of the string, and then I need to take the string as well. Okay, C in S. Now what should I do? I need to maintain the count who have already entered into the bar, right? So the number of boys equal to 0 and the number of girls are equal to 0. So let me run on this string. Okay, so what should I do? If it is equal to a boy, I will simply increment the count of boys. Else I will simply increment the count of girls, right? So where should I put the condition? Here itself. So if the number of boys are more than twice of the number of girls, okay, then simply break here. And what you need to output? The number of boys who have already entered into the bar and the number of girls who have already entered into the bar. So the output is B plus G. 714. The sample input is getting passed. Correct answer. So now let us go to the next question. So let us go to the third problem in the division 4 CodeChef Starters contest. So the problem name is Beautiful Garden. So let us go through the problem statement. Chef has a beautiful garden that contains n flowers. Okay, and initially all the flowers are in bloom. However, each flower is a bit shy. Once plucked, the ith flower takes ti days to regrow and bloom again. So assume there are four flowers, okay, and all the flowers are initially blooming. Blooming means they are shiny. Assume, okay. So all the four flowers are blooming. Let's say each flower has a shyness character, which means once if I pluck this flower out of the garden, then this one will take ti number of days to regrow this flower again to bloom. Okay, this flower once plucked, it will take ti days to regrow and bloom again. Okay, so chefs love plucking flowers but also wants his garden to look beautiful. For this reason, he insists that there are at least k flowers in the garden blooming at each and every time. Okay, so whatever flowers, how many flowers you are plucking each day, and there should be at least k blooming flowers so that the garden doesn't look bad. Okay, let's assume k equal to 2 and the number of flowers are 4. Initially all of them are blooming. Can I pluck this? Yes, because there are 3 blooming flowers. Can I pluck this? Yes, there are 2 blooming flowers. So now can I pluck this? No, you cannot. Why? Because there is only one blooming flower. How many blooming flowers does the chef needed? At least 2 blooming flowers. Okay, so I cannot pluck these 2 flowers. Okay, so over a d days, number from 1 to d, chef will pluck some blooming flowers. On any day he can pluck any number of flowers. Assume there are d number of days. Okay, let's assume d equal to 2. Okay, so in each day, let's assume in day 1 and day 2, in each day he can pluck any number of flowers as we want. But if he plucks any number of flowers, there should be at least k flowers should be blooming at all the time. Okay, so in day 1, can I pluck this one flower? Yes, you can pluck. Can in day 2, can I pluck this second flower? Yes, you can pluck. Let's assume d is equal to 3. Okay, now in day 3, in day 1 I have plucked one flower and still the condition is remaining satisfied. In day 2 I have plucked one more flower and still there are 2 blooming flowers. And in day 3, can I pluck one more flower? No, you cannot. So in day 3, how many flowers can you pluck? Only 0 flowers, because you cannot pluck any flower, right? So in total, in these 3 number of days, how many flowers have you totally plucked? Okay, in you have plucked total 2 number of flowers, right? So this is the question. But there is one more thing. Whatever flower that you pluck, this flower will take ti number of days to regrow again. So once it is regrown here, let's assume when you reach day 3, assume this flower has regrown, so you can pluck the same flower again. So which will become 3 flowers in total in 3 days, right? So let us go through the question. So if you see here, if the ith flower is plucked, if the ith flower is plucked on the day x, it will take x plus ti. It will take x plus ti time to regrow and bloom again. What is this x? You can simply assume this x as index. What is this ti? This ti is nothing but flower number. Okay, you can assume this as flower number. Now if I put this in this example only, this will be index 0, we all know that. And let's assume this is 2. Okay, what is 0 plus 2? 2, right? So 1, 2, 3. So by the time you reach this index, this flower will be bloomed again, regrown and bloom. Okay, so that is the overall question, guys. So what do we need to determine is maximum total number of times chef can pluck any flower in d number of days. At each day, how many flowers can he pluck? This one followed by all the d days. Okay. Okay, I got the same question, I guess. Okay. So let us go to the sample input. Sample input. So you are given how many flowers? You are given. Let's assume n as 3. N is nothing but number of flowers, and k is 2. There should be at least 2 blooming flowers, and I need to pluck flowers for the next 3 days. Okay, so let us see how the answer we got as 3 in day 0. Sorry, in day 1. How many flowers can he pluck? Okay, so the flowers are 1, 1, 2, right? So I can pluck the first flower in the day 1. Okay, so in day 1 I can simply pluck one flower. Okay, in day 2 there are 2 flowers, right? So how many flowers there should be blooming at any day? There should be 2 flowers. But if you see here, when you pluck this first flower, it will regrow in how much time? What is the index of it? 0. The first flower will bloom again by 0 plus 1 time, which is nothing but 1. So by the time you reach, when you pluck this and by the time you reach index 1, this flower is regrown and blooming again. So on day 2, which flower can you pick? Can you pluck? The first flower itself, which is the 0th index flower. Yes. So I will pluck the same flower again. Now again, if I move to the next index, and this first flower will be blooming again, which is regrown and blooming again, right? And on day 3, what flower can I pick? I can pluck the same first flower, right? So I will be plucking the same flower. So in total, in 3 days, I am able to pluck one flower every single day. So my answer for this test case is nothing but 3, right? Now let us see the second test case. So the number of flowers are 2, and what else? There should be at least 2 blooming flowers, and the number of days I want to pluck the flowers is for next 10 days. Okay, so the flower number is 2 and the 2 and 3. This is index 0, this is index 1. Okay, so day 1, let us assume on day 1 how many flowers can he pluck? Okay, he can pluck the first flower, right? So if he plucks the first flower, but the moment he plucks the first flower, how many blooming flowers are left? There is only one blooming flower, right? So in day 1, can he able to pluck any, like can he able to pluck at least one flower? No, because even if he plucks at least one flower, then the number of blooming flowers which will be less than k. So my answer for the second test case is always going to be 0, because he is unable to pluck any flower from the garden, right? Now let us go to the third test case. Okay, so the third test case is n is equal to 3 and the minimum number of blooming flowers are 0 and the number of days are 5. This is kind of interesting. Try to focus on this. So the numbers are 5, 4, 7. Okay, so think of it like this. Okay, let us assume if I pluck this flower, how much time will it take? 0 plus 5, right? On day 0. Whereas if I pluck this flower, how much time will it take to regrow it again? Day 0, it will take 0 plus 5. So this will take 5 days of time, this will take 4 days of time. Now among these two options, which one will you select? Obviously the minimum one. Why the minimum one? Because it will regrow faster. By the time you reach day 1 or day 2, you will have a flower which was regrown already, right? So whatever data that has given to you, you will simply first sort it. You will sort it. Okay, now let us go through this. This is index 0, 1, 2. Okay, so there are 0 blooming flowers, so I can pluck all 3 of them. Okay, so on day 1, so I will simply pluck the first one. Okay, so my answer is 1. Okay, on day 2 I will simply pluck the second one, so my answer is 1 here. Okay, on day 3 I will simply pluck the third flower, my count is 1. So on day 4, what should I do? Are there any flowers left in the garden? No, there are no flowers left. There are only 3 flowers, and you have already plucked all the 3 flowers. Are there any regrown flowers by the time you reach the day 4? Think of it. How much time will it take to regrow this first flower, which will take 0 plus 4 days of time? So by the time you reach the index 3, which is nothing but day 3, are there any regrown flower? No, there is no regrown flower on the day 3, right? So can I simply say the time is like on day 4 you are unable to pluck any flower, right? So what about on day 5? What about on day 5? Which is day 5 is nothing but 0 based indexing is 4. Okay, so on the day 5, this first flower, which will take 0 plus 4 units of time, will be regrown. This flower will be regrown, right? So on day 5 you are able to pluck this regrown flower again, and satisfying the k equal to 0 minimum blooming flowers as well. So what is the answer here? What is the answer here? 1 plus 1 plus 1 plus 0 plus 1, which is nothing but 4. Did we got the 4? Yes. So this is the question, guys. So how do we come up with the logic for this? How can we come up with the logic for this? So there should be some way knowing that. So I will be using 2 things here. Okay, let me show it to you. Okay. Okay, it's better to write. Let me write it down. So n equal to 3, minimum blooming flowers are 2. How many days are there? 3 days. And the flower values are 1, 1, 2. The indices are 0, 1, 2. So there are 2 things which I will be using for this problem. Okay, to solve this problem I will be using 2 things. So one is nothing but which will tell me how many flowers are there to pluck. Like at the particular day, are there any flowers to pluck from the garden or not? Okay, this is my first thing. So we will discuss what data structure it is afterwards. Okay, and second data structure will tell me, are there any flowers who have already regrown? Let's say on day 0 you have plucked one flower, you have removed from one flower from the garden. Okay, and by the time you reach this day 4, this flower has already regrown. So in this second data structure you will be tracking all the removed plucked flowers. So by the time you reach day 4 you will simply look up to this data structure and see, are there, like by the time I reach this day 4, are there any flowers which have regrown already? So this data structure will help you doing that. Okay, so let us simply name them. So this one, let us call it as available flowers. So at any time you can pluck all these flowers from this available flowers. Okay, so second thing is nothing but delayed flowers. So what is this delayed flowers is telling? So once upon a time you have plucked one flower, so future forward in this day, are there any flower which has already regrown and blooming? So if there are any flowers which have already regrown and blooming, you will simply pick it from here and put it in the available flowers. That's it. So let us see the first test case. So you have 1, 1 and 2. The index of 0 is 1, the index of 1 is 1, the index of 2 is 2. Okay, how many minimum blooming flowers should be there? 2, right? So let me pluck the first one. Let me pluck the first one. If I pluck, let us maintain one more count. Count is initially it is 0. Okay, so I will pluck the first one. How much time will it take to regrow this one plucked flower? So the data type in the delayed flower is a pair kind of format. Okay, int comma int. Why int comma int? So the first one will tell you the time. Okay, the second one will give you the flower number. Okay, The first one will give you the time, the second one will give you the flower number. In this case, the flower number is 1. So how much time will it take to regrow and bloom this flower again? Which will take, it will take 0 plus 1 time to regrow and bloom again, the flower number 1, right? So I will plug this out and I will put the time followed by flower number in the delayed flowers. Done. So now I will go to the, now my count will be 1. Okay, now I will go to the next index. Okay, by the time I go to the next index, just check, is there any flower which has already regrown when I reach this particular day? When I reach this particular day, is there any flower which has already regrown? Yes. What is that flower which has already regrown? This first one. How can you able to say that? Because the index, because of the index, this index is nothing but day. So according to zero based indexing, this is day 1. So at the day 1, there is one flower which has already regrown and blooming, right? So what will I do? What will I do? I will simply remove this from the delayed flowers and I will simply add this flower into my available flowers. Okay. Now again, out of these available flowers, which one will you select? Exactly the one with the minimum value, right? So again on day 2, you will, again on day 1, you will be picking the same flower. Okay. Now how much time will it take to bloom this again? Again 1 unit of day with flower number as 1, right? So on the second day also you are able to pick, you are able to pluck one flower such that there are at least 2 blooming flowers. Okay. Now you will go to the next index. Now when you reach the next index, if you see here, are there any flowers which are blooming by the time you reach the next day? Yes, there is one flower which is already blooming, right? So what I will do is I will simply remove this from the delayed flowers because it has already regrown. So now I will simply put it back in the available flowers. So on day 3 also I am able to pluck one flower such that there are at least 2 blooming flowers remain at any cost. Okay, so my answer for this is 3. So let us do the same thing for the next one, not for the next one, but the last one. Okay, because for the next one there is nothing here, because k value is equal to n, obviously the answer is 0, right? So the number of days, the number of flowers are 3, the k value is 0, and the number of days are 5. If you have still not understood, you will understand with this example. Try to focus. So 5, 4, 7, right? 5, 4, 7 are the flower numbers, but we have seen we will simply sort them. So this will become 4, 5, 7. Okay. Now let me reset the count. Okay. 4, 5, 7. This will become 4, this will become 5, this will become 7. Okay. So initial day 1, what flower can I pluck? I can pluck all the 3 flowers because the minimum flowers required to bloom at any day is 0, right? So I can pluck any number of flowers. So let me simply pluck first flower from the day 0. Okay. If I remove the flower from day 0, how much time will it take to regrow? The day plus the time, the flower number, which is 0 plus 4. So it will take 4 days to regrow. Okay. So it will take 4 days to regrow, and the flower number is 4. Okay, done. Now what is the next one? 5. I will simply pluck this. How much time will it take to regrow? 1 plus 5 is nothing but 6 days to regrow the flower number 5. Done. Now the flower number 7. How much time will it take to regrow? 7 plus 2, 9. 9 days to regrow the flower number 7. Done. So on day 1, I am able to pluck one flower. On day 2, I am able to pluck one flower. On day 3, I am able to pluck one flower. Now what about on day 4? On day 4. So on day 4 means in terms of zero based indexing, it will be day 3, right? So on day 3, is there any flower which is already grown, regrown and blooming again? No, the index is not matching, right? So on day 3, the number of flowers that I can pluck are 0. Now what about on day 4? Now when you see here that by the time I reach day 4, there is one flower which has already regrown and blooming. So I will simply make this as available flower. So on day 4, I can simply pluck the same flower again. So with the time as 4, 4. So on day 4, I can simply pluck one more flower. So in total, how many flowers have I plucked so far? 1, 1, 1, 1. total 4 flowers, right? And that is the expected answer. So we will simply use these two data structures to maintain the available flowers and regrown flowers. Okay, so we will be using multiset. Now, what is a multiset? We all know what is a set. A set is a data structure which can hold only unique values, right? But whereas a multiset, this will also allow you a duplicate values as well, and the data will be sorted. Okay, so we want sortedness at each time when we remove a flower and add a flower, and this can be done with this. But the flowers number can also be duplicate, right? Okay, so let us jump into the code now. First, what you need to do, you need to take the number of like you need to take the input n, k, and d, n, k, and d. So first c in n, c in k, c in d. Now what you need to do? So I will simply insert all the flowers into a multiset, which is nothing but available flowers, because all the flowers are available for plucking, right? So long int multiset available flowers. So for I equal 0, I less than n, I plus plus. So I will take directly into some random x variable, and then I will simply insert all this into the available flowers. Okay. Instead of taking into an array, I am taking it directly into the available flowers. Now, what is the second data structure I need? Again, a multiset, but with a pair, because I need to store two values for every item that I am inserting. One is the time and one is the flower number. Okay, so let me call it as delayed flowers. Done. What is the next one? I need to maintain my answer, right? So int answer is equal to 0. Now what do I need to do? So there are d number of days. Each day I need to pluck one flower, right? So I will simply iterate on the number of days. I equal to 0, I less than d, I plus plus. Okay. There are no test cases, right? Okay, there are no test cases. No. Now what is the next step? What is the next step? So first I need to check in my by the time I reach this particular day, is there any flower which has already started blooming? How do I check that? Simple. If delayed dot size is more than 0, which means it is not empty. Okay. And what should I do? Delayed flowers dot begin. Okay. If the first value which is equal to day, let me expand this. Okay. Now I think you can see. So if there are some delayed flowers, but by the time I reach this particular day, one flower has started blooming, which is this condition will handle that. So if that is the case, then what should I do? I need to add this to the available flowers, right? So how do I insert this to the available flowers? Simple. Available flowers dot insert of delayed flowers dot begin dot second, because second one is the flower number, first one is the time. Now once I add this flower which has already started blooming, now do I need this flower in my delayed flowers? No, right? So let me simply remove that. Delayed flowers dot erase of delayed flowers dot begin. Done. This flower is deleted. Now this is one step. What is the next step? What is the next step? Now at each day I need to pluck some flowers, right, from the available flowers. So how do I know that whether I can pluck this flower or not? Like if I pluck this one flower, there should be at least k blooming flowers, right? How do I handle that? Can I simply say if available flowers dot size is more than k, then I can pluck some flowers on the day, right? So available flowers dot arrays of available flowers. But before erasing, we need to store this, right? So let me call it as long int flower number. Okay. So flower number is nothing but available flowers dot begin. So I will get the first flower. Okay. Now what should I do? So once you have got the first flower, you can simply pluck it out. Arrays of available flowers dot begin. Okay. Now what is the next step? Once you pluck this flower, this should be regrowing for the next d days. So you will be inserting this plucked flower in the delayed flowers. Delayed flowers dot insert. So how will you insert? This flower number which is nothing but day plus this flower number, comma, what do you need to add? The flower number. Okay, that's it. So each day you will be plucking some flowers out. So how do you count that out? Here itself, answer plus plus. Okay, so once this is done, you can simply see out answer enter. Okay, let us see, are there any syntax errors, something like that. Okay, there is one syntax error. Okay, we don't have D, right? We have D here. D. What else? Here also we need only D. Okay, we have test cases, my bad. So let me add test cases, C in test cases, while test case decrement. I forgot to add it. So let me format the code. Okay, run. Okay, we are getting 104 as our answer. Let us have a look at it. Okay, so here there is a small mistake. Like here we are comparing it with D, but that is not D actually, that is I, because I stands for day number. So by the time you reach this day, it should be regrown, right? So this one is changed, and here also it is not D, it is I. Okay, so now let me run the code for it. 304, 304, sample input is getting passed. So it is got submitted. Okay, but don't close yet. There is one more solution. I will give you one hint. Try to work on it. Okay. Codes that we have discussed and the codes that we have submitted just now, it is okay. It is taking extra space as well, right? It might take an extra space, but we don't want this, right? So, is there any approach that you can come up with where the space complexity is constant? Okay, we can think of it like this. Let's assume, I will give you one small hint. Let's assume that there are day equal to 10 number of days. Okay, and on day 0, you have plucked one flower. Okay, let's assume the flower number is 2. Okay, on day 0, you have plucked one flower and the flower number is 2. So 0 day, 1 day. Let's assume one based indexing on day 1. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 days, and on day 1 you have plucked the first flower, right? So how many times can it regrow this only one flower? How many times can this flower can regrow within 10 days? So can I simply say, if you pluck this here, it will regrow again here, again here, again here, again here. How many times did it regrow here, right? So can I simply say the number of days divided by the flower number, which is nothing but 5 here. So is it regrown 5 number of days? It is regrown 5 times within the span of 10 days. Yes. So this is one observation. Okay, this is one hint. And second one is, let's say there are let's say there are 5 flowers. Okay, let's assume X, Y, let's assume A, B, C, D, and E, and the number of blooming flowers are 2. So at each day there has to be at least 2 number of blooming flowers, which should be blooming at every single day. Okay, so if there are 5 flowers, there should, what will I do is I will simply lock in the last 2 flowers, which means I will not even pluck these 2 flowers at any cost. Whatever plucking has to be done, this one has to be done by the first 3 flowers only. So if you pluck this, by the time you reach here, this flower should have been regrown, right? So your answer, which is this one, should be used for the first 3 days only. Forget about the last 2 days, because these last 2 days, which means these last 2 flowers, are used to satisfy the condition for k equal to 2 minimum flowers. So whatever plucking has to be done, it has to be done by the n minus k flowers only. Okay, so this is the 2 hints that I will be giving to you. You can come up with an easier approach with this constant space complexity. Try to work on it. So yeah guys, welcome back to the next problem in the CodeChef Starters. So the problem name is palindromic score. Okay, so let us go through the problem statement. Alice has three types of characters A, B, and C. She is given exactly X copies of A and Y copies of B and Z copies of C. Alice must use all these characters to form a string. She is free to arrange these characters in any order. Okay, so after Alice forms her string, Bob makes a move. Okay, Bob will choose one character from either A, B, or C, and then he will simply delete all the occurrences of that particular character. Okay, Alice's final score is defined as the length of the longest palindromic subsequence of the string after Bob's deletion. Now, here the main part is both players will play optimally. Both players will play optimally. Alice's goal is to arrange the characters to maximize his subsequence answer, where Bob's goal is to delete a character such that Alice should get the minimum answer. Alice's score should be minimized. So determine the maximum achievable score that Alice can obtain. So we will understand the entire question with the help of the sample input. Now if you see here, the test cases are big, but x, y, z values are very small. Okay, these values is very small. So the first one. So each test case you will be getting three values: A, B, and then C. A stands for the number of copies of A. So in the first test case, the number of copies of A are 3, and the number of copies of B are 0, number of copies of C are 0. So what Alice can do, he has only one option in this case, is to generate a string which has the longest palindromic subsequence. And here, but you have only one copy of A, right? Which is, you can generate something like this, A. So Alice has created this string. Now what is the duty of Bob? He has to delete either A, either B, either C, such that you should not be getting a longest palindromic subsequence. So here Bob will simply remove all the occurrences of A, leaving you with an empty string. So the answer for the sample test case 1 is 0. Now let us go to the next one. Okay, let us go to the next one. So here A count is 4, B count is 3, C count is 0. Okay, so what Alice can do? What Alice can do? So 4 plus 3, he generate a palindromic subsequence with the characters of A, with the characters of B, 4 A's and using 3 B's. Can he generate a palindrome? Yes, he can, right? He can do something like this: A, and then 3 B's, and then followed by 2 more A's. Is this a palindrome? Yes. So according the moment he constructed this palindrome, what is the answer that he can gain right now? 4 plus 3, which is 7, right? But now Bob's turn. Bob will either delete all the occurrences of A, or Bob will delete all the occurrences of B. Can Bob delete all the occurrences of C? No, he can't, because there are no occurrences of C. But still, you need to understand one point is that both the players will play optimally. This is the important point. Okay, it's not always that Bob is going to delete the higher occurrences. Okay, the highest occurrences. So now what do we get here? Bob will simply delete the occurrences of all A's, which is nothing but 4, and Alice is left with only 3 characters, and this is a one subsequence which is forming a palindrome, right? So after what he have constructed, the answer that he got now is 3. So the best answer for this test case is 3. Now what about this? You have 2 A's, 2 B's, and 2 C's. What he can do? Can Alice form a palindrome? Let us see. He can put C in the middle, followed by 2 B's somewhere here, and followed by 2 A's somewhere here, right? So B here and then A here. So what does Bob can do now? So Bob has three options. Bob has three options. Either he can delete all the occurrences of A, and either he can delete all the occurrences of B, or either he can delete all the occurrences of C. If he deletes all the occurrences of A, what is the value that Alice can get? What is the longest palindromic subsequence that Alice can gain? Something like this. A is removed, then he is left with a palindrome of C subsequence which is having a length of 4, right? Okay. Now if he removes B, this and this, then this also is forming one subsequence palindrome which is 𝗟𝗃𝗺𝗃. This is having a length of 4, and here 𝗏𝗃𝗃𝗃b, this is forming a length of 4, And if Bob chooses to delete C, what he can get? The answer. So if he deletes C, he will get something like A, B, B, A. Again, the answer is 4. So the answer that Alice can get is 4. Now you can think of something like this. Will Bob always remove the maximum value of A? Will Bob always remove the maximum value of A? No, right? Because let us go with an example. Let's say the number of, we have three things, right? A, B, and C. So let us assume that A value is 2 and B value is 3 and C value is 1. So with the help of these characters, can we form a palindromic subsequence, longest palindromic subsequence? Maybe we can think of something like this. One A goes here and followed by 3 B's, followed by one more A, and we have one more character. But wherever we put this character, it doesn't become, the entire string doesn't become a palindrome, right? So either you can go with 2 plus 3, which is 5 characters, or 3 plus 1. You can't go with 3 plus 1, which is 4 characters. So 3 B's and 1 C. Wherever you put this, the entire string doesn't become a palindrome. So this is what Alice can form in the end, right? So what is the answer right now that Alice can gain right now? Alice can get the answer as the longest palindromic subsequence is 5 here. In this case, it is 5. Okay. Now Bob's turn. Now Bob, if Bob removes A, then what we are left with? This A and this A will be gone and we are left with only 3 characters. So if Bob removes A, the answer that Alice can gain is 3. If Bob removes B, what is the answer that Alice can gain? If he removes B, then Alice can gain A and A, right? So the answer here is 3 actually. Why? Because C comes into the middle, forming a new string of ACA. So 3 is the answer. What about if Bob removes C? What is the answer that we can gain? Same, 5, right? If Bob removes C, our answer is 5. So we don't know what is the character that Bob can remove. Bob can go with A, Bob can go with B, Bob can go with C. We don't know that. But Bob's most important aim is to give you the minimum answer among all these values. Bob's aim is that I will delete that occurrences of a character such that you are getting the minimum answer. So what we will do is we will simply try all the 3 possibilities. What if Bob chooses A? This is the answer that I will get. Let us store it in X variable. What if Bob removes B? This is the answer that I will get. I will store it in Y. And what if Bob removes C character? This is the answer that I will get. I will simply store it in Z. So what is the main aim of Bob? Is to give you is to minimize your answer. So we will simply consider the minimum of X, Y and Z. That is the answer. But how exactly the code looks like? So if you see here, if Bob removes A, assume there is a function, and in this function I will pass 2 parameters. If Bob removes A, the parameters are B and C. So B is nothing but 3, C is nothing but 1. With the help of 4 characters, can I form a palindrome? With the help of 4 characters, can I form a palindrome? Think. Can you form a palindrome with 4 characters? Like 3 characters of B, 1 characters of C. No, you cannot form a palindrome, right? So in this case, you will simply return 3, which means you will ignore 1 character out of this. Okay. So we will try to discuss these conditions in the code. Okay. So let us quickly open the IDE here. Okay. So now let us write the code for it. First, I need to take the number of test cases. Okay. So for each test case, what should I do? I need to take the count of A, count of B, and then count of C. So let me take it, count of A, count of B, and count of C. So we don't know what does Bob will remove. Okay. So first, what will I do? I will calculate my answer. What if Bob removes the A occurrence? If Bob removes the A occurrences, can I form a palindrome? Like what is the maximum subsequence length of palindrome that I can form with b number of characters and with c number of characters. Okay, this is possibility 1. And possibility 2, what if Bob removes my b character? So what is the longest subsequence palindrome that I can form with a number of characters and with c number of characters? And I will go with possibility 3. What if Bob removes c character? What is the longest palindromic subsequence I can form with a and b characters? Okay, so I will simply print minimum of these three possibilities. Why minimum? Because what is the aim of the Bob is to simply minimize your answer. So in whatever scenario you choose, Bob will always give you the minimum of all the possibilities, right? So now, what is this find answer? How do we write it? How do we write it? So it accepts x number of characters of one type and y number of characters of one type. So we have seen just now, if we have both odd and odd, you cannot form a palindrome, right? So if one of them is even, if one of them is even, okay, I will simply return x plus y, because with the help of both the characters you can form a palindrome. You will simply return x plus y. But if both are odd, like in the case of 3 and 1, you cannot use 4 characters, 3 of a, 1 of b, to find a, like assume like this, a b. Can you form a palindrome here? No, right? It definitely has to be, you have to remove one character. Either you remove b or either you remove a. If you remove a, b comes in the middle, something like this, right? So here, if both are odd, then you will simply return x plus y minus 1. You need to definitely remove one character. That's it. Now let us run the code. 034, let us see. Yes, it is getting accepted. Yes guys, our code got submitted. Thank you for watching the video. Thank you for watching the video, and if you want to see such more content, please do subscribe, share and like the video.